Then he went back to the university, that is the University of Agriculture in Sciences in Kerala, Kerala Agricultural University, and completed his assignment of professorship there, and again rejoined at the campus at ICRISAT here. So in addition to his assignment in the Kerala Agricultural University, Dr. Kesava Rao also has worked earlier in Central Research Institute for Dryland Agriculture, and as you know well that he is quite very much immersed in the analysis of agroclimatic data, water balances, and also the climate change scenarios for different regions as well as its impact on the different crops. He is one of the best team members in the group of RDS and does helping hand to every member, because as you know, climate parameters are required for all the studies, and that's where he is attached or is in touch with every team member in the institute, and not only in the RDS alone as such. With that, I would request Dr. Kesava Rao to take the floor and deliver his seminar on the topic of evidence of climate change increase in the semi-arid areas of India. Dr. Kesava. Thank you, Dr. Vani, for your kind remarks. As all of you know, climate change due to global warming has become a hot topic, not only in this country, everywhere. And there are several studies on climate change just happening. People take temperature as an indicator, rainfall as another indicator, maybe some other parameters. There are several works going on in India as well as other countries on understanding the climate change and also its impact, particularly on agriculture. So we thought that today we will deviate a bit. Instead of taking the basic parameters, what about the climate change? That means the area, whether there is an increase in the areas under the different climates in India, if so, what are the trends? That is my topic of presentation today. And the content will be something like, say, global warming, a small introduction about impact on climate, and then what data we have used for this presentation and methods we have adopted, and what are the results in respect to the changes in the semi-arid area. And then I would like to spend some time on the ICRISAT hypothesis of hope, that is addressing the climate change issues and how we look forward. And this is actually something which I gathered from Munich Rain, which gives information about the last 30-31 years about the natural catastrophes from 1982 to 2000. In that, the red bars indicate about geophysical events. But other than that, if we take at least the sum of the green, blue, and the orange bars, green are meteorological events, and the blue are hydrological events, and the orange bars are climatological events. If you see, there is some trend, increasing trend worldwide in the occurrence of natural catastrophes. And 2010, they mentioned that the second highest since 1980 is 960 events. Is it related to climate change? I mean, we don't argue for that, but I would like to say that there is worldwide increase in the natural catastrophes, basically because of the increase in the meteorological, hydrological, and climatological events. What's happening in India about the temperature? If you take the whole country's annual temperature and take the anomalies of these values, what we see is that almost starting from say 1980 onwards, 1975, 80 onwards, the anomalies appear to be increasing towards the positive side. There are very few times the anomalies are towards the negative side. And for the last 10, 12 years, the anomalies are consistently positive. That means that the temperature invariably there is an increase in the annual mean temperature for the whole country. And 2 years back, IMD has declared that 2010 is the warmest year on record in the last 110 years. Because of the 0.90 degrees centigrade above the 1960 average. So we know that there are changes in temperature and definitely warming is noticed in India. What will be the manifestors of this the higher temperature? Will it be simply the increase in the temperature? What this is a slide borrowed from IPCC. There could be three possibilities. The first possibility is that there will be a change in the mean temperature, so the mean will be shifting towards the higher side. Secondly, means may not shift much, but the variance will increase. That means the maximum temperature will be higher, but minimum temperature may be lower. So because of the mean may not change much, but the variance may change. The third most possible thing is that both will change. That means the mean temperature also shifts as well as the variance. Perhaps this is what we can look for our age. Coming to the moisture rain, all of us we know that the monsoon is so important for India, both for agriculture as well as other water resources. And how the monsoon onset over Kerala is changing for the last say 140 or 141 years. If you see, starting from 1871 up to 2012, including this year, we see that there is no trend in the onset of the monsoon, even in the last 140 years. Though you may see that the red line there is a slight fall. That means the monsoon onset is slightly earlier these days, instead of say June 4th or 5th. It is coming sometime on June 1st, or maybe May 28th, 29th. But it is not significant. In fact, this year we know that the onset was on 5th June. So, and you predicted almost not there are 5 days. What about the rainfall in the whole southwest monsoon period? We see, in fact, there is no trend at all. That means what we see is that if the global warming is affecting the onset of the date of monsoon over Kerala, I am talking only about Kerala, because that is the first gate. At different places is different. Okay. And about the rainfall, we don't see really any great trends in the rainfall. But if we take at a smaller area, district level, CRIDA have reported in 2009 a mosaic of changes. This is based on some more than 100 years data of annual rainfall at the selected rainfall districts for India. What we see is that we do not have a uniform zone. You will find sometimes a green district next to the orange and next to blue. That means neighboring districts have got different trends. So it shows that whatever the climate change we are talking, it may not be manifested all over the country in the same way. But there are regional differences, or even at the district level there are differences. And then when we do an analysis on the rainfall intensity, particularly over central Goswami, they have reported that right, there is not much change in the total rainfall, but there are changes in the intensity of rainfall. So they classified say up to 100 millimeters, more than 100 and more than 150. If you see the green line, the line indicates between 5 millimeters to something 100 millimeters. There is a slight decrease in the number of events. Whereas if you see the blue one, which is more than 100 mm but less than 150, or the red line at the bottom, which is more than 150 mm, there is a significant clear increase in trend. So when you sum it up, what happens is that there is a rising trend, significant rising trend, not only the frequency, but also the magnitude of extreme rain events. At the same time, decreasing trend in the frequency of moderate events. Because what happens is finally, you may not have any great changes in the total rainfall, but there are changes in the amount of rainfall per day. Because of the great fear that there can be increase in the hazards related to heavy rain in the central region. They have chosen central region for this purpose. What happened sometime back in Andhra, you see 2012 April, January 10th to 11th. In fact, January is not actually a rainy month in Andhra Pradesh. Only by almost December, the last month. But in 10th, 11th January 2012, Kavali Nellore received almost 169 millimeters of rainfall. The effect is almost 7 billion rupees lost. And even the color of the chilies is affected because of the marketing is very much affected. Not only the total loss, but even sometimes the rain will change the color, the quality of the product. So this is what I call give an introduction to the topic, what's happening in the country, what others have already attempted to do that one, what we have planned and what we have done this time. So this particular presentation we talk about the changes in the area under different climates in India based on long period data. And this is the data we have collected from Indian Meteorological Department. The data period is for 34 years, 1971 to 2004. And the data is actually for 1 degree resolution, 1 degree by 1 degree is 1 pixel. And for the whole country, when we do that, there are about 351 pixels. And IMD itself has derived this data based on 395 stations for temperature, as well as 1800 stations for rainfall. And they have used the GI technique, spatial, anthropogenic technique by it's slightly older version, but they have given this, the Shepherd method. So we have taken this data, we have multiplied the data again, and each pixel, for all the 357 pixels, we have developed the database, and we have in-house developed the software for working out the personal transpiration, water balance, and several other computations. And the method we have used for understanding climatic water balance is that for every pixel we need to have the soil available water holding capacity that we have obtained from the National Bureau of Soil Survey and Land Use Planning map. Then we have observed the PET, personal transpiration from harvest method, following harvest method, and rainfall we had. And we use the modified water balance of conservation method. So for all the 52 weeks for all the 34 years and for all the 351 pixels, we have computed weekly water balance of the data that is available with us. Now from this we have observed the humidity index and also the aridity index. From these to the balance we get the moisture index, which is actually used in the classification of climate by Thornthwaite. And even now Thornthwaite classification is considered one of the best classification for climate all over the world. And as I said earlier, we have used this Thornthwaite classification to understand how much is the area under arid, how much is under semi-arid, where is the humid, moisture, humid, these 6 types of climate in the period 1 and also in the period 2. When we work out that one for all the pixels and use the IDW method in GIS, we arrived at this kind of map. Here we have divided the period because in the 34 years, we have taken up to 1990 as the first period. The reason for it is that normally anywhere in the world, 1961 to 90 is considered first climate normal period, and previous 1931 to 60. So we thought that we will end up to 90, whatever the period. Because the data is available only from 1971, we have taken 1971 to 1930. We can compare this data in future with other classifications. And the second we have taken from 1991 to 2004. And data once we get say another 6 years or 8 years data, we will be able to compare it again with the same one. So when we see the map, it may not be very clear for you, but There are changes, particularly in the semi-arid area, that is in not red but say darker this orange color. Particularly if you see the Madhya Pradesh, compare the left map and the right side. In fact, more areas are under this orange color. In the same way, in Bihar also, there was a very small area initially, but now it has expanded to this level and also new. Whereas in Rajasthan, the arid regions are expanding from the western side towards the southeast side. From this map, we understand this, but we want to quantify how much is the case for each state. So what we have done is, we have selected about 18 states in India. These are the 18 states we have selected for this analysis. The reason is that the Jammu and Kashmir and the Northeast Assam and other areas we have not considered because there are one or two small problems in the data at the border area. And we would like to concentrate more on the dry and other areas. So these two reasons we have taken only these 18 states. But however, these 18 states almost make up 84% of the total India's geographical area. For these states, this is how actually we have observed these are the results. So 1971 to 90 and then 91 to 2004 AC. If we take Madhya Pradesh, if we take say arid, initially there was no area under arid zone, second period after there is nothing. But in the semi-arid area it was 17.96 million hectares, it has increased to 21.78. So there is an increase of 3.82 million hectares of area under semi-arid. From where it has come? Because the area under state is constant, it cannot be different. So that mainly came from the dry subhumid area. Earlier it was 12.85 which fell to 8.77. The difference is say 4.08 which was much of that has gone to semi-arid and variability has gone to dry subhumid. So from this what we understand is Madhya Pradesh almost 4 million hectares under dry subhumid have been, much of that has been converted to the semi-arid in the last 20, 14, 15 years, and I think that trend will continue even now, we know that one. Whereas if you take Bihar, almost the same trend is seen. If you see again minus 3.48 million hectares have been converted to either semi-arid or much of it, and very little has been gone to humid. So these are the two tests as an example where there is a great change. More area is coming under semi-arid zone. But if you take a state like Orissa, there are little changes. There is not much change between the period 1 and period 2. The greatest changes are less than 1 million hectares. 50.7.507 is still less than 1 million hectares, which was actually instead of going there is actually these minus 1.66. These are actually Orissa, the semi-arid and dry are slowly coming towards moist humid and humid. So what we see is that there are areas which are becoming drier from wetter, and there are areas which are becoming from saturated to drier. We find that one. The same case is even seen in Karnataka. When you put the whole thing, when you select some 14 the states to see that one, put it in the order, the Madhya Pradesh very clearly you can see that one. The almost say 4 million hectares have been converted to either semi-arid or some part of moisture, like that one. So there are great changes in the area under various climates. And when you put the whole thing is just one country, what we see is that one, the greatest change is in the dry subhumid area. 10.7 million hectares of the dry subhumid area has been gone down. That has been shifted towards wetter side as well as drier side. From this, what we understand is that if you consider that say dry subhumid and moist subhumid are more or less the moderate climate, the theory which Goswami and others we were witnessing, the moderate climates are slightly changing towards either drier side or towards wetter side. So that gives really to some extent an alarm to us. The moderate climate, almost 10.7 million hectares, they are shifting some of about 50% hectares they gone towards wetter and about 47-48% they gone to the drier side. Now, once we understand this thing, this global warming and monsoon relationship, many times we see this thing, and many people are this question, why there are failures in the prediction of the monsoon rainfall. Let us not talk about the daily rainfall or weekly. Even the total season rainfall, many times we find that there is no consistency in the forecast and this thing. And there are lots of studies have been done. One study says that because of the higher level of errors there, it cascades more and more errors, and finally the predictability is actually falling down. So to finally what the study says that the monsoon weather forecasting becomes very tough, and it may be almost quite as difficult as what we were doing earlier. But is there a solution? Yes. High power computing. Even though I understand that the supercomputers are being used by the entomology of national center building weather forecasting, and even for Agroclimatology, IMD, IIT, and others. But still, the computing power is not sufficient, many publishers say. So now the country is going ahead, and I'm sure in future we will have better forecast. But what happened this year, if you see, as on just day for yesterday, we know that one, the Honorable Minister for Agriculture issued a statement of 400 districts in India. They received much less rainfall. Even in Karnataka, where we know that one almost out of 176 taluks, 142 taluks have been declared as drought affected. So, as on today, say 30th, 31st July, if you see the 4 regions of the country, all the regions, they have lesser rainfall compared to the normal this year. But let us remember that as usual, the forecast, the longer forecast was, we get almost 96% to 104% of the rainfall. The problem is that the previous slide says that there are problems. The monsoon prediction has become more and more tough and difficult these days. But still, there is hope for us. Now, once we know the problem, we know that the people who have not committed anything to the climate change, definitely we know that suffer the greatest livelihood consequences that we know. Now we know the problem. Do we have any solution? Yes. The solution that is proposed by ICRISAT hypothesis of hope. Here, all of us know this, but I am explaining this for the benefit of others who are actually joining the seminar purchase. So, there are actually 5 bars here. The first bar is actually the low input practices on the current climate, where we always talk about the 1 ton agriculture for the impact farmers in India. That is the present condition. Now, if there is climate change and it really comes in the near future, then there will be a reduction in the yield compared to what we are getting now, but the reduction is small because we are already getting very low yield. But over that one, if you take the third bar where we have the improved practices, management and other practices, the yield can be improved by almost maybe 1.5 to even 2%. But added to that one, if you have, say, adopted germ plasm, then it may go up even to 2.5%. And currently, what we are getting the low input in the current climate, if we can add the improved practices and the improved germ plasm, we may expect 2.5 to 3 times increase in the present rainfall yield. So that is the ICRISAT hypothesis as I understand. And how do you achieve it? There are one is to go for better crop varieties suitable for the future climate, like short intensity cultivars, which can withstand high temperatures, or the ICRISAT 267, the first CBN hybrid, or the ICTV 9714, which can escape the thermal drought. Through crop, we can to some extent address the issue, and I am happy to say that we are working on the modeling of the ICRISAT 2670 as well as the natural resources ecologics are being conducted in ICRISAT as well as other places in the country. And the other thing is the integrated water management to build resilience, either by way of HC2 or in situ water conservation and crop and soil system, where we can conserve water and the reduction of the runoff on the soil and the different better management practices will get the better yield. And not only to the people who have the land, but other people who doesn't have the land, how to increase their income by maybe value addition to the PGNP or maybe vermicomposting vegetables and other activities. And another important point what we are doing and we propose to do further strengthen these activities to share the agroclimatic information by wall writings with the farming community. And this way, or train the farmers to take their rainfall reading on their own, such that they will understand the climate, rainfall, its effects, and others. And train the students at watershed, such that they understand about how to use an automatic watershed, what kind of data we can get, and training bringing more awareness among the community, including the students. That is one way what we can think of. And finally, the equity efficiency that is important. The adaptation of material strategies, they finally lead to efficiency and of equity among the community and enhance the economy, and it will take care of the environment. And to end my presentation, what is the way forward? As the Secretary General, Honorable Secretary General, University of 19 says, climate change has no respect for borders and effects that we have seen in India. And the efforts of which it is that has already validated in reducing India, we need to strengthen it further and optimize it and harness the potential of integrated water management and diversification of livelihood options. These are all actually I mean for assessing the climate change and variability. And adding to that one, the improved economic awareness at local level and combined with the weather insurance package and policies and institutions. And not only that, many times there is a complaint that always climate is the problem and then everything is depending on it. In fact, the other way is also so. Climate also play a key role in climate solutions. Talking about climate play a role in agriculture. Agriculture also should play a key role in climate solutions like carbon sequestration. So many other ways we can agriculture should play that. And in addition to that, now let's come to saying that whatever the results have presented, they are based on the certificate data, physics data, and based on certain time tested methods. But if you use some other solution, some other method, the results can be slightly varying. But the fact remains that these changes are existing. So we are actually now proposing for further rigorous analysis using the high resolution data. And we have no time to lose. We know that global warming tolerance are not very far. Once it goes, there is no looking back. So only in is adaptation and mitigation is crucial. So I think it is time for me to take on. And I thank all of you. And then particularly I would like to put on record my personal thanks to Dr. Suhas Swami, who is my mentor here, and also to State Crawford and the management who have given me the opportunity here. And this work is actually based on a project under NICRA, National Initiative of Climate and Agriculture by ICR. We are thankful to ICR. Thank you. Thank you, Kesava. I think now before you take off, you may have to answer some of the questions people have. So, any questions? Kesava, you mentioned about increasing temperature. So there is also the opposite effect also. The night temperatures are going down. So you need to look at both of them. So how do we explain that? And maybe night temperature cooling down may have a better effect on coffee. So how do we manage or explain that? The night temperatures going down is seen at very few places in the country. In fact, ICRISAT is one example, where we find that during December, January, up to February, in the last 35 years, the minimum temperature during these 3 months there is a decreasing trend. And we find the reason for that. That is because of the wind speeds have lowered in those months. Because of there is more radiative cooling and there is some mixing of the air layers. And this type of conditions were there in Gujarat, some place or other. But in general, Punjab and other areas, in fact, the night temperatures are actually going up. That's the reason in the Rabi that more affected by the higher minimum temperature. And maximum temperature in many places there is a increase in the effect. That is that. But one has to see why a small pocket has got this kind of trend and the neighboring pocket has got almost no trend or even an opposite trend. So we need to have a micro level there, and we are not trying to get the 0.5 degree data, because that will be able to get data. Once we identify the hotspot, we go for the actual station data. In terms of the adaptation, like you mentioned about like the breeding, focus on the new crop, the new type of crop, and also watershed that could be the previous collective action for this large area. But we did hear about the economic practices that are individual farmers and adapt. Sometimes they take the crop also. Only the variety the crop also takes place. So the focusing on the agronomy is also important, but I didn't hear about that. So whether I'm telling to explain that whether it's not important or consider the farm individual household as unit that can adapt. If they can take variety, they can take crop also. So the household will remain, they will move away. That part also needs to be considered in terms of climate change adaptation. Yeah, very right in saying that agronomy is very important. In fact, it is a very important part in our watershed management. In fact, that is included. But because of the sourcing has been 20 minutes, I have said that this thing. But agronomy is such an important thing. We actually do that in our all maybe I will put the again tell what I said for the last. It shows that the area shifting from humid to semi-arid, a bit more dry, semi-arid. So there's been quite a bit of a shift. My question is only whether this shift has intensified in the last year, because this shift keeps happening. You hear of many coastal areas becoming, changing because of various factors. Is this change happening more and faster in recent years than earlier? In fact, it's an important question. We find that the temperature changes are happening at a faster rate in the past, say, 20 years or so. That's what we understand. And definitely the faster rate of increase in the temperature will definitely change the climate much faster. We know that. But to prove that, we need to have more data, and we will be getting that information very soon. Such that when we have, say, last 100 years data, every 10 years what's the change? So that we know the rate of change is more in the past than 2 decades. In fact, that's what we are trying to do with the CRE data. Very good.
There's a question coming in from one of our virtual participants, CPC Rao, and he's asking how confident are you about the changes in agroecology, given that they are derived from different numbers of years of data? And if you could also repeat the question into the microphone for those listening at home.
You want me to repeat the question?
Yes, so that people who are listening online.
I mean, the question is by Dr. Kesava Rao from Nairobi. The question, as I understand, is that how sure we are about the findings and the changes in the economy, that means the changes in the climate. And the second is,
given that they're derived from different numbers of years of data.
okay, the point is that when you have used 34 years data, you are getting this result. Suppose you use, say, another set of data, what kind of results you get? Yes, that is very clear. In fact, we have attempted this already, but the results, still there. We have about 109 years of data. We have observed almost a similar results we got from the CRE data of 2009. But that is still we are working. We are confident that there may be degree, a slight change in the magnitude of say 4 million hectares, maybe 3.6 million hectares, or maybe 4.3 million hectares. But the fact is that there are changes and semi-arid areas increased in Madhya Pradesh and Bihar. That is very clear. We have that. So one mind-boggling issue here is that you have analyzed rainfall test, rainfall data of type, both spatial and temporal. It is evident that there is a lot of variation, lot of variability, very high. But do you think any significant difference with respect to quantity of the total quantity of precipitation to see? Irrespective of the variability, when you take the total, whether you find any significant difference in that one. Second, so then you conclude in the policies you said what is our message? Whether we have prepared to deal with this, suppose how accurate to predict this, if you would have this one predicted last year, at least you should have taken some mitigating measures, for example in Karnataka. So when you advocate these watershed measures and all, so when there is no water, there is no rainfall, how far an ordinary a small farmer can take up whether really they can invest on this when they don't have adequate purchasing power even to survive. So how effective our strategy? What is our preparedness to deal with these this one? How accurately we can predict? Okay, to answer the first question, in this particular presentation we have not touched the rainfall trend. What we have done is taking rainfall, taking soil properties, taking soil pressure, how do we actually try to classify the climate based on standard method and see how the climates are changing, the areas under different climates are changing. So I have not attempted the rainfall trend because that is done by several persons already, but still there is a lot of activity. That's the first one. Second one, the first is adaptation, then comes mitigation. First is whenever we have problem, first we adapt to that one. Then we try to mitigate such that the same thing will not occur many times. So the adaptation strategy, we understand that watershed, integrated watershed management is one sure way of adapting to the climate change. And I know that there is one research called Patancheru, where we got drought in 2001 and compared to the normal years, how the farmers could escape the brunt of the low rainfall in that particular season. And as you said in Karnataka, we know that one there is almost no rainfall. Today only one of my colleagues is saying that in Harvard, Mysore, and other areas, no sowings were there. Simply you see only the black fire. We know that one. It's when you got such a major setback, maybe they were not in you, but when you got aberrations to some extent where we can deal with, yes, we are already doing that one. The results are there, published. Is one I think which we are. When I actually had a comment on IMD forecast. So some of you might have read the leading article in the Kingdom yesterday. It's actually a very fair investment type of the forecast. But those who are not familiar, you can either descend IMD or you can cast in the sun. You just want to explain exactly what IMD forecast was this year. The forecast for IMD says 96% to 1 plus or minus 4%. We know that one. No, that's the point. They said that that initial forecast indeed said there was a 50% chance of that, and therefore there's a 50% chance it will be deficient. When they updated the forecast, in fact the chance of deficiency was increased substantially. The point of the Hindu article was that for political reasons they are forced to give that figure. And in fact they have a probabilistic forecast that's actually pretty accurate. But they chose only to give that one figure is not good. Yeah, there is a very good article yesterday which I think is pretty fair assessment of the state of IMD forecasting.
Yeah. I think Peter, I have one comment about the low temperature on the campus. I think vegetation index has something to do with it also, because I think we see more vegetation with time. I think the lawns and the area, vegetation area, also that is a comment. The question is really when we are trying to measure a index, aridity index or whatever, what is the minimum time span required to measure it accurately? Because one can use 10 years, 20 years, 30 years, but there must be a way to find out what is the minimum time span required to measure a change properly or accurately.
When we talk of climate, as per the WMO specifications, continuous 30 years of data is required to say it is a normal, and that is the one which will actually indicate that either whatever the index is, which is rainfall or aridity index, humidity index, XYZ, whatever the index is, we need to take 30 years. So the 30 years is also defined as 1931 to 60, 61 to 90, that is, those are the 30 years. We just cannot take any year and then add 30 years. So these are normal. So minimum 30 years are needed to understand. So that is the idea that it will be stabilized in this 30 years. Almost all the variability in the parameters is captured in this 30 years. So whatever the average you get out of the 30 years should represent the norm. That is the idea. Normally it's taken on 30 years. So in the second we have taken up to 90. Such that if we get previous data we can add, and after 90 what we get we can always compare.
Yeah, because there must be a time, where the equilibrium really climate could take place, and we can say that this is a stabilized kind of change. So that's what I was interested. As in soils or anything, there is a time lag which is needed and change occurs. That change should stabilize us also, so that we can really measure it confidently. Thank you.
Last question, short one from Pandit.
To just you said the 30 years time data will be enough, but most of the IPCC studies are more than 600,000 year old ice core data. Yeah, they are based on, and then they say +1 to +4 degree change in temperature or whatever. So I mean, I'm just asking, is it the realistic? Which one is the minimum given 30 years? That I understand, that much English I understand, but I'm saying that the data basis of IPCC right from 2002 to 2008, 9 is
Yes, sir. No, normally
I just wanted to know the similarity.
No, already the point is that based on the available observed data, using the instrument, we hardly have 200, 250 years of data, not more than that. Immediately, if you take the data only from 1871. That is the
But one is very good. You said 0.09 for Semi-Arid Tropics, that changes in the temperature. Something like that based on this.
That is based on 1901 to 2004.
But that is a quite good indication.
Yes, sir. It's 0.56 degrees centigrade. Now, while I said normal is, both IMD and WMO, they published normal only for the 30 years. They released one from 1931 to 60, now they have released 61 to 90, next one will be released 91 onwards. That is the standard for any country, 31 to 60, 61 to 90. That is considered as the normal. But when we do our analysis, we try to compare with the normal, but we also see the degree variations, other variations. Then we have the longitudinal data. We try all possibilities to understand the whole area to assess the climate change in a better way. We are trying to improve. Good. Thank you very much, Dr. Kesava Rao, as well as all the participants.